Hello there, Mr. Sutton here, bringing you the Algebra 2, Chapter 2 quiz review solutions on quadratic functions. For this problem, we're trying to graph the function g of x equals x minus 2 squared plus 1. So there's a couple ways you could do this. One way to do this would be to just find the vertex and plug in another point and then use symmetry to get 3 points and graph it out. The way I'm going to show you, though, is basically to just transform the parent function of this. So the transformation happening, if we look at it from that perspective, this x minus 2 in here is giving us a shift to the right 2, and the plus 1 outside is translating us up by 1. So we have translation right 2 and up 1. So let me write my parent table down now. So we have an x squared for the parent function, and that has negative 2 comma 4, negative 1, 1, 0, 0, 1, 1, and 2, 4, the 5 points that I like to use with your basic parabola here. Now for the new rules for x and y, since I'm going right 2, I'm going to write x plus 2 for my g function here. Since I'm going up 1, I have to do y plus 1. So going back and adding 2 to all my x values, this is going to become 0, negative 1 becomes 1, then we have 2, 1 becomes 3, and 2 becomes 4. Doing the same idea for the y values, but adding 1 instead, we have 4 becoming 5, and then we have 2, 1. This is 2 again, and 5 again. All right, so putting that all on the graph, we've got a 0, comma 5, which is right up here, and then here's 1, comma 2, 2, comma 1, 3, comma 2, and 4, comma 5. And then just draw the parabola through those points. For this problem, we're trying to graph this parabola that is in standard form. Because it's in standard form, I'm going to start by using the vertex formula, negative b over 2a, to get the x value of the vertex. So that's going to be negative 12 over 2 times 2. Negative 12 over 4 gives us negative 3. And then if I plug that back in, I can get the y value of the vertex. So 2 times negative 3 squared plus 12 times negative 3 plus 19. Negative 3 squared is 9. 2 times that is 18. Here we have a minus 36. So 18 minus 36 is negative 18. Add a 19 to that. Now I've got 1. So let me just graph that. Vertex of negative 3 comma 1. So that's going to be right. So I'm just kind of thinking ahead at what some of my y values are going to be. Just in anticipation of some larger y values, I'm making my grid lines go by 4s instead of 1, just to throw that out there right away. So if I'm doing negative 3 comma 1, that's like a quarter of the way up this first grid line. Now here's why I made my grid lines so crazy. The y-intercept, which is this plus 19 here, I need to be able to graph that as well. So I'm going to go to 0, comma 19, which is all the way up here, and now I can graph that and fit it on the same grid. Now I can get one more point by reflecting my y-intercept over the axis of symmetry that goes through my vertex. So that reflects over to here at negative 6, comma 19. And with 3 points, I can now graph that parabola. For this problem, we're trying to graph this parabola that's in intercept form. So the fastest way to do this is just going to be to find the x-intercepts and then use those to find the vertex. So my x-intercepts, the x values that zero these factors out, we've got 1 and negative 3. So the way to get the vertex out of these, we're just going to average these together, and that'll get me the x value of the vertex. So we have 1 plus negative 3 over 2. Negative 2 over 2 gives us negative 1. And then plugging that back in to get the y value of the vertex, we have negative 2 times positive 2, which is negative 4. So negative 1 comma negative 4, that's our vertex. Graphing all this out, we have my x-intercepts at, we had negative 3 and 1, and now we have negative 1 comma negative 4 for the vertex, and that's enough to graph the parabola through those 3 points. For this problem, we're trying to write an equation of a parabola that has a point of 5, comma 3, and the x-intercepts negative 1 and 7. Since they're giving us the x-intercepts, the easiest way to do this is going to be to start with the intercept form. That's y equals a times x minus p and x minus q. So I'll start by plugging in -1 and 7 for the p and the q here. So that'll be x plus 1 and x minus 7, because it's minus whatever you're plugging in. Next up, I have to find my a value. The only way to do that is if I replace the x and the y with the point that they gave me. So for y, I'm going to put -3 in for that. And for the x's, those are both going to get this 5 that's in that point. All right, let's go ahead and solve for a now. So this is going to be 6 times -2. So we have -12a equals 3. So then we can have a equals -3/12 or -1/4 or -0.25, however you want to write that. So plugging that back in then, we have y equals -1/4, I just reduced it, and then x plus 1 and the x minus 7 from this equation earlier on. For this problem, we have a table showing us the speeds of sound in water at various temperatures. Apparently, the temperature of water changes the speed of sound, which is kind of interesting. And this is quite a change in speeds here. There's like a gap of 400 feet per second. That's crazy. Anyway, we want to write a function that models this data and then use it to figure out how fast sound is going when the water temperature is 100 degrees Fahrenheit. So we would probably expect it to be somewhere between 4960 and 5049, but we'll see. So the way we're going to do this is we're going to use Desmos to do a quadratic regression. So let's go to Desmos. So here's Desmos. And to do a quadratic regression, I have to first enter this stuff in the table. So let me press the plus here and pull up table. And let me just do the x values first. So 32, 50, 90, 120, 180, and 212, the boiling point of water. Can't go any higher than that. And now let me get my y values, or I guess these would be t and s values in here. So 4603, 4748, 4748, there we go. 4960, 5049, 5095, and 5062. Awesome. Let me expand this a little bit now so I can see a little bit more of it. There we go. And I'm going to press this magnifying glass just to look at all my beautiful points that I just did. And we can see that this definitely would lend itself to a quadratic shape if we kept going in this direction. So to do that, let's press the regression button right here. That adds a regression. Now this is normally going to be a linear regression, but you can change this with this drop-down menu and make it anything you want. We're going to choose quadratic regression. And now we see it's a much better fitting curve here. That gives us this equation, -0.028 x squared if we round it off, and a whole bunch of other stuff that I will just write down here if you're interested. So this is the quadratic regression formula here, or at least for this particular quadratic regression. Now what they want us to do is to figure out the speed of sound when the temperature is 100. This equation we wrote gives you the temperature based on various speeds. And just to make this make a little more sense in terms of the table, I'm going to change my variables. So this is actually s equals t squared t and all the rest of it. All right, there we go. Now it actually matches the variables they have in the table. So I basically have to plug 100 in for the temperature. And whatever I get back, that'll be my speed of sound. So let me go back to Desmos. And I'm going to take this equation and copy it into another entry. And I'm just going to press this button to do that quickly. It's a nice little button there. Now what I am going to do with this entry here is instead of calling all this y, I'm going to call this just, we'll just call it s of x. There we go. Now I've got my s function. It's got an x instead of a t, but I don't really need to replace all those. But this allows me to plug anything I want in there. And now I'm just going to do s of 100. And that comes out to 4,990 roughly. So I guess it does round up to 91 because it had a 0.8 after it. So that's 4991 feet per second. For this problem, which is an honors review problem here, we're trying to write an equation of a parabola given a focus and a directrix. So in order to get the equation of a parabola, we are going to need to first figure out which form we're using, since it's the focus directrix kind of form. So is this going to be an x equals or a y equals parabola? And the easiest way to find that is just to look at the formula for the directrix if you have it, or look at which coordinate is changing. In both cases, we see that y is the thing that's changing. We change from -6 to 6 here. So that is telling us that we're going to have a y equals 1 over 4p x minus h squared plus k formula. If the x value were changing, or you had x equals for the directrix, then you would write x equals all this stuff, but we would have y in here and k, and then h would be out here. All right, so given all that, we need the vertex, the h and the k, and we also need this p-value. We'll get the vertex first. The vertex is always halfway between the focus and the directrix. So I know the vertex is going to have an x value of 0 because this is a vertical parabola, so it's in line horizontally with the focus. But we're going to have to average the y values together to get the y value of the vertex. So we're going to have -6 plus 6 all over, let's see, that should be all over 2. There we go. And that's going to come out to actually just 0, 0. So not too bad. So plugging things in, actually we also need to find the p-value. I can get the p-value by just doing the focus minus the vertex on that variable that keeps changing. So that would be -6 minus this 0 here, which comes out to -6. Another way you can get the p-value is if you do the vertex minus the directrix. That would give you 0 minus 6, which would also give you -6. All right, so we've got our p-value, we've got our v. It's time to plug all of this into my y equals now. So I've got y equals 1 over 4 times -6. And since h and k are both 0 from this vertex, this whole thing just comes out to x squared if I simplify it. And so I can fully simplify this then to -1 over 24 x squared.